So, gentlemen, welcome to my throne room for the 8th time, not even 7th. But at any rate, I'll be making as many recordings as I have to until I get this over with. What we have here today is not a machining project, or rather, it is a design of a machining project, and some of my modifications that I have added to it. The original design is actually not done by me, but it is an idea from Ollysworkshop, and it is an ER collet chuck which has a lever actuation. Now, my idea was to completely omit the levers, as the levers require a secondary external fulcrum point that they are going to pivot against to actuate the central sleeve via the lugs and push it against the spring washer stack, thus relieving the collet of the clamping forces, allowing the stock to pass through. Ollie's design is pretty much confined to these three components. That would be pretty much the original design. I'm sorry, as you can see, and as I have said, I have done this 7 times before this recording, so you can see my fingers smudging and smearing the graphite all over the paper. I hope that the camera is actually less sensitive to it than my own eye. There are some modifications. By the way, you should really go and check out Ollie's video, because me rambling about this is really not going to be productive if you have got no idea what I am actually referring to and referencing off of. So go check Ollie's video, use that as a starting point, then come back if you have time. The general idea is to take the ER collet nut, use that as a stationary taper, pretty much the same way the regular ER collet style uses the long taper as the stationary taper, as one, or rather an integral part of the body which gets chucked or clamped, or however you want to say, affixed to either a tool holder, a spindle, or whatever, where the nut is usually used to loosen the collets, relieve them of the clamping force, or to exchange them. Over here, the nut is solely used to exchange the collets, and once you have picked out the collet of the desired diameter that you require for the job at hand, you take the nut, you thread it onto the main body, and you actually break the taper lock and release the forces by actuating this central floating sleeve, or rather a floating cylinder with a appropriate ER collet taper imparted to it via the lugs. Now, this isn't an optimal technical blueprint, nor is it a blueprint really of any sort, but I suppose it will do the job that I need of it. Disregarding this section, it is a mistake and product of idiocy and of me drawing this whole thing at 4 in the morning rather than at some civilized time when I'm more awake. There are some other mistakes, some of which I have managed to correct, some of which I cannot correct because they are drawn in marker. To cut the rambling short, the main design, the Ollie's prototype, relies on a cylindrical section with a bore for the lugs. Now, I'm not sure really anymore if Ollie's design relies solely on the threaded section of the lug to retain the lug and to support it against the leverage applied to it by the levers, or in my case by the split nut that would be applying the leverage via the angled slot. However, my design exchanges that. I'm sorry, I'm going to be going all over the place because this is primarily a video for Ollie, and if you have watched his video, then you pretty much know as much as Ollie does about his design and can thus follow my train of thought. If the lugs solely rely on the thread as a fixturing point, then all the shearing forces, or rather all the forces that force the cylindrical sleeve down the main body and against the spring washers, are of course going to be trying to shear the lug at the thread section, which is of course the weakest section of the lug itself. Even if you have a thread undercut, it's still the weakest section. Thus is I at least believe, a change implemented in a manner where the lug threads into part of the sidewall, the internal section of the sidewall, and it has a cylindrical section in the sidewall that would be bored, because reaming out this short of a section would be more of a challenge than just boring it out. And let's say that this is a cylindrical 10mm section, and let's say that this is an M8 thread. That means that you have a square shoulder of sorts, a hard shoulder, that can bump up against a hard shoulder over here. Thus would the lug be supported fully by the cylindrical section, and the thread would solely have to pull the lug into the cylindrical support area. The cylinder otherwise is mostly unchanged, I believe. I'm not even sure if this is a change of sorts, but that thing plops into here. Everything should be hardened to steel, everything should be ground, machined, lapped, however you want to, whichever process you want to apply, but everything should pretty much have tolerances that are either sub-micron or sub-100th of a millimeter, which is what, half a thou or something like that. The half a thou clearances would be for the slots and the lugs. You have one slot over here that the lug protrudes through the main body and gets caught by this other slot, which is drawn wrongly. This is drawn at 45 degrees, but it should be rather at 15 degrees, purely to give you more leverage over the lugs themselves. This thing is plopped in here with a perfect matching fit that is 1 micron or sub-micron, and relies on a film of high pressure lubricant to provide a bearing for the system and to allow you to actuate the thing itself. And the thing rests against the spring washer stack naturally until the ER collet nut with a collet is threaded down, and then you should actually first actuate this part down with whatever method you're using and allow the nut to fully seat. Now I believe that this is a modification that Ollie hadn't applied to his design, but I would clock in a ER collet nut on a lathe by the short taper that it has, and I would take a boring bar and would remove the last, or rather first few threads that the nut has, thus making a cylindrical section. As you can see, this main body has a cylindrical section over here. The idea being that you are no longer relying on threads themselves as a fixturing, or rather locating mechanism. They are going to be fixturing, but they're not going to be used as a locating mechanism. The cylindrical portion over here, with a very close tolerance to the cylindrical portion of the nut gained by removal of threads, would actually ensure repeatability and precision of the short nut taper. The nut rear section would also be faced in the single setup, as the threads would be removed to fully seat up and bump up against this square flat shoulder, which would in turn, with the cylindrical reference surface, act as a dual alignment mechanism, which would thus guarantee the repeatability and high precision of the nut, and would allow the nut, or rather the nut's short taper, to actually behave as a reference surface, or a surface that the collet would repeatably bump up against, or rather snug up against, by the rear sliding sleeve. The main body is otherwise a cylindrical section with a shoulder over here. Please disregard this section that I have added with the marker. As said, it was 4 in the morning and I was already losing my shit. And disregard this crossed out section. This actually stays. It shouldn't have been crossed out. So the main body is a thread for the nut with a alignment geometry over here, just a bit of a aesthetic taper, and an outer diameter that has a perfect fit, also somewhere around 2 micron clearance, with this internal diameter of this multi-piece nut or a ring, however you want to call it, but we'll get to this part a bit later. It is that way all the way to here, to this shoulder, which is an interlocking section along with this reduced section for this segment of the split nut. This is just a hard stop, essentially, where the split nut would be retained fully in this small section. Now one could of course add some O-rings and such purely to fully negate any vibrations and dampen any nonsense, but what with 2 micron clearance between these parts and sub-micron clearance between the internal bore and this cylinder, sub-micron tolerance between the alignment geometry of this and the nut, also the nut is going to be fully retained here by the threads, there should really be no vibration, no nonsense that could induce fretting, corrosion, or any such undesired effects. The main body, I believe, in the original lacks any wrench catches. Now you can add as many wrench catches as you need, but I believe that more than 4 is pretty much overdoing it. I have drawn in 1, which implies 2, because this is supposed to be a cylindrical section, mirrored fully. But at any rate, without a wrench catch over here, you're not going to be threading and unthreading the ER collet nut properly. There's no way. The same goes for this split nut that allows you to actuate the lugs which protrude from the side of the main body over here. The spring washer stack is identical as in the original video, or rather as with the prototype that Ollie made. I believe that his part affixes to the collet backplate, collet chuck backplate from the rear, and I just replicated a rough geometry to represent such a mounting system, but it would be most easy to fasten it to a chuck backplate from the rear. With that said, we have gone through this slot, which is actually 2 slots. Everything is mirrored, I hope I said it already, and everything is hardened tool steel ground to essentially sub 2 micron tolerances. Some of them are actually even tighter, being sub micron, but other than the slots themselves. with that said, I have gone through the collet nut changes, through the wrench catch, through this small section of added geometry for this split nut design, potential addition of O-rings and such. The O-rings would be better suited to retain the high pressure lubricant that you would apply to this whole system at assembly or in the service intervals. So you would add an O-ring over here at the top, you would add an O-ring over here at the base or over here in this section, and that would pretty much constrain or retain the high pressure lubricant that would provide a film and a bearing surface for these two parts. The internal section needs no such help because it is supposed to run on a sub-micron tolerance, so yeah. What little oil is or other lubricant is in there would remain in there for long enough between the two intervals. And the lugs, as I said, are made in such a way, as you can see, I have modified the original drawing the day after, because I have drawn the thread section a bit too long. So it mimicked the same issue actually that relying solely on threads would cause. Okay, that pretty much does it for the prototype design, or rather for the 3 or 4 parts, the ER collet nut not being drawn included. And we are left with this section, which is my generous donation to the world of design. It is also somewhat lacking in completion, but and it also has a lacking section over here that I have not fully filled in, or rather shaded with graphite, because I have started writing and I have drawn a pointer over here, so I guess you can understand that if this part is over here, then it is equally over here, given that this is a cylindrical part. But as I said, okay, let me start over. This is a split ring, or rather a split nut design. This section is also drawn wrong. This should be missing entirely from here, and this should be a nice, slightly reduced threaded section over here, just as over here. These are actually, as you can see, dual locking nuts. Dual locking nuts for what? You might be asking. For this. This is also drawn wrong, but I wanted to give you an idea that this is a ring actually, rather than having just 2 small, practically one-sided blades drawn over here. You take a piece of solid material, you slice it in half. I am of course slicing my pencil down the center line, but you would of course not be slicing it down the slot and down the wrench catch. Of course you would be slicing it down the sides in this case, but since there would be no wrench catches and no slots at that time, you get the point. We're talking about rough stock at this point. You would take a solid piece, rather, let's turn it around. You would slit it, you would clamp it back together. You would of course preferably grind it properly on a surface grinder. You could also take a square section, because that would probably be easier to fixture with a faceplate or with a four-jaw chuck. Some faceplates even have 4 jaws to them, so you can actually rely on a 4-sided piece of material, probably with best odds. So you would slit it, you would pop it in the lathe, you would bore out the inside, you would, as I said, the inside should be ultimately ground to a 2 micron tolerance with clearance with this outside diameter. You have a reduced section over here, an undercut really, that interlocks around this section. As I said, these are going to be 2 parts, so you're going to be able to pop one around, pop the other from below, and apply the clamping ring, or rather the retainer ring, and thus unifying the whole design. Now my mind was a bit addled at 4 in the morning, and I have completely omitted the idea that one should actually add maybe a secondary retainer ring in this section, probably with another 2 retainer nuts for it, merely because you have the wrench catch over here and you're gonna be wrenching against it, and this whole section is technically unsupported. The ring bumps up against this tapered shoulder and is in full contact, pretty much bearing great contact against this outside diameter. As I said, this is supposed to be a slightly reduced threaded section that the ring can pass over. The rear section also is outside diameter, a faced section, an inside diameter, and an undercut that becomes one with this larger undercut. That is drawn a bit wrong. I could have drawn a less clearance over here, but I wanted you to be able to see it on the camera, so this is a compromise between my 4 a.m. insanity, between mistakes in drawing, between my considerations of what the camera can see and what I could actually see at that a late hour. And that being said, you pop the 2 parts over this. This section interlocks over here, this section interlocks over here, and the whole thing can slightly move back and forth. Slightly. This is not supposed to have 2 millimeters of clearance. This is supposed to have pretty much, I don't know, 5/10, no more, of clearance, or rather of free play back and forth, because you do not really need free play. You just need this part to be able to fully and seamlessly, or rather without any contact, rotate against this body. It's not going to be able to rotate fully because it's of course going to be pinned down and will have a limited travel side, or rather in a rotary manner, by the lugs. This section, as I said, will also have a wrench catch drilled in from the side, which will allow you to, in tandem with another wrench catch over here, to actuate this part against the body, forcing the protruding lug that is gonna be, as you can see, the lug would technically coincide along all 3 slots, or rather the bore, the slot, and the other slot. So with a 15-degree taper rather than 45, it would grant you quite some leverage, plus the wrench leverage that you would already have, and would allow you to actuate this central cylinder, as I said, breaking the taper lock and relieving the pressure on the stock. I'm sorry, I'm having a train pass by, so I'm gonna shut up for a few seconds. Okay, it is gone by far enough that it is no longer as audible as it was initially. Okay, yeah, where did I stop? I've got no idea. We've gone through these parts, we've gone through this essentially, and we've gone through this. Am I really done already? This is the shortest recording out of all of them. I guess the 8th time is the charm, but I'll add some redundancy if it is redundancy, or explain it if I haven't already. So this being a 2-piece design, you chucked it up in the lathe, you applied all the turning geometry that you have to apply over here, the external diameter, the threaded section, you make 2 nuts that are going to retain the sleeve. You add the taper. Of course, the nuts are going to be a completely separate process, but I guess you can follow what I mean. You have some other geometries, the internal reduced sections, the catches, shoulders, whatever. And you unchuck it from the lathe, you split the 2 parts, you put them on the mill, and you mill in a 15-degree slot over here, and you drill in the wrench catch in it. That's pretty much how you gain this piece, or rather these 2 pieces. You of course do the same thing with the other piece as well, because you have 2 wrench catches. You want to you have 2 lugs, so you want 2 slots, and you really want 2 wrench catches, because you shouldn't really add more, being that this is a split design. You want the 2 to be in the middle of the part and to be as supported by the material as possible, as well as possible. And yeah, I think I said everything about this ring there is to be said. It is drawn wrongly, but it is a hollow section that has a bearing fit over this, literally sub-micron, purely to properly fit over this. You have 2 nuts that are going to push the ring against the tapered shoulder and fully constrain this whole assembly into a single integral piece. Another such ring would be quite beneficial in this rear section, but one would have to rely on some very thin nuts, or rather would have to extend this body not to obstruct the wrench catch over here. I haven't said it in this recording. I'm sorry, I'm trying to remember what have I said in this recording and what have I said in the 7 previous recordings that have been scrapped. But when the lug design is fully threaded into this section, the thread does not protrude into the stock feeding bore of the cylinder. The lug, as you can see, has 2 centimeters of length over here that correspond to the sidewall thickness of the main body, which is 2 centimeters. At least I'm talking in centimeters or millimeters, doesn't really matter, because I'm purely referring to the millimeter paper. Every single of these small blocks is 1 millimeter, and every large block is 1 centimeter. So I'm enumerating dimensions, but those are deceitful dimensions. They are lies, essentially. The paper is producing them. I just drew things in a manner that made it easy for me, so the final design is entirely up to you. This is purely a proof of concept, let's put it that way. But the threads fully engage, the cylindrical section provides support for the lug. The section over here, this 2 centimeter long section, fully protrudes from this, or rather from the slots out of the main body, and then you have a 9 millimeter section over here with the last millimeter missing, because this section over here is 1 centimeter wide, and you do not want the lug to protrude from this side wall and interfere with the retainer ring. And that, I believe, does it. I'm sorry if I'm a bit erratic. As I said, this is the 8th bloody recording. I actually have an open YouTube studio window right in front of me, with subtitles being written down for a 32-minute.56 video. That is the 7th recording that I wanted to just justify and deem passable, because I was getting real pissy yesterday and was about to enter a conniption. But here we are again. I really hope that I'm not going to be having any sound issues, because 5 out of 6 recordings have been scrapped because of some sound issues that are intermittent and that I am unable to diagnose or rather to locate the source of. So yeah, I'll have to get some better equipment. But to stop the rambling, Ollie, as I said in the comment, I have drawn this. I'm most glad that I have inspired some changes and modifications of the prototype. And just with the comment itself, I hope that this video and that this sketch expounds upon my mental processes and line of thinking in regards to how I would modify your prototype. I of course wanted to alleviate the external separate fulcrum for the levers and the levers themselves, because that requires you to affix the secondary, or rather the separate fulcrum, to the headstock or to whatever, and I do not really like applying pressure, as you have stated yourself, to parts not designed and intended to be used in that manner. I do not like machine modifications that make use of parts of machines that are not intended to be used for, well, whatever modification you're applying to the machine. I'm aware that this forces one to halt the spindle rotation fully to be able to use it, which this design would have solved, and this would have been a lever actuated design. As you can see, this piece is quite akin to this piece and would also catch in here, but unfortunately this piece would have to remain stationary because it would have a lever. This should actually be facing the other way, but given that I'm lacking paper over here, I've just turned it as I saw fit. Would have a lever, or rather a pair of levers attached over here, and would droop to one side of the ways of the lathe, of the bed, better said. So if this is essentially stationary, this has to turn within it. You would have to have a bearing solution of sorts, merely to be able to have this part running in this section, and that would be a more complicated, more annoying design to implement. I suppose one could do it relatively easily by splitting it over here, making an interlocking geometry, applying another retainer ring over here, relying on certain bearings that could be applied within this section. You would have to modify this or this part a bit purely to be able to insert the bearings, but it would be a bitch. It would be just adding unnecessary wear components nonsense. You could even rely on a 2-piece bronze journal bearing, but then you would have to oil it constantly, because journal bearings aren't bearings, they are another deception in the form of a bearing, because they bear actually nothing. The oil, or rather the hydraulic film, is actually what supplies the bearing. So yeah, I'll stop rambling. As I said, this is completely disregardable. I hope you ignore it and forget about me rambling these few seconds. And that all being said, I'm glad that I have filmed this, and I will actually be glad that I have filmed this if this video isn't going to be plagued by sound issues. But yeah, that'll do it for this video. As I said, thank you, Ollie, for the inspiration, and I thank all of you for watching this, if any of you have even been interested enough to try to keep up with my incoherent, insane, inane rambling at high speed for the last, I don't know how many minutes. All the best, and until next time, bye bye.